Good morning, everyone. Thank you very much for coming to my TED Talk, or not TED Talk. Zero downtime upgrades with Alembic. I'm going to talk about Alembic and SQLAlchemy and Python and database migrations and some strategies that you can use in, we'll say, more production-style applications to manage the life cycle of your database. Before we begin, my name's Stephen Finucane. I'm a senior software engineer at Red Hat. Normally, we'll say, my day job was previously working on OpenStack, and recently I've switched to looking more on OpenShift, which is Red Hat's Kubernetes variant. As anyone that was here last night for the lightning talks would know, OpenStack is Python-based. It uses a lot of the common Python libraries, including SQLAlchemy and Alembic. So a little bit of background about the problem I'm trying to talk about today, and we'll get into solutions then. We'll say, so SQLAlchemy is a norm. It allows you to represent your database models in Python code. It doesn't handle things like migrations. That's what Alembic's for, and we'll get to that in a moment. It's, if anyone here, show of hands actually, who's worked with SQLAlchemy? Pretty much everyone, yeah. Show of hands again, how many have used it with Flask? Okay, I thought there'd be more actually. Yeah, so SQLAlchemy is pretty much the ORM of choice. Django has its own one built in. But SQLAlchemy is the thing that's effectively captured most of the Python market. It's incredibly powerful, comes with a lot of tools, most of which you're probably not going to need, but they're there in the bag when you actually need to dig into them. Little pointer, SQLAlchemy 2.0 is coming out in the next couple of months. If you have a production application that's using SQLAlchemy, I would recommend you start looking at the upgrade path for that now, because it's quite intensive. And as we've been discovering in OpenStack land, it takes a long time to get everything migrated across. And there's quite a good chance you have bugs in your existing application based on pre-2.0 design patterns. Alembic then is a tool designed by the SQLAlchemy authors. Show of hands again, who's used Alembic in their application? Not quite as many, okay. So yeah, Alembic allows you to evolve your database schema over time. So we'll say if you're adding new tables, dropping columns, adding constraints, dropping constraints, this kind of thing. It comes with a couple of nifty features, including the ability to auto-generate your migrations based on, we'll say, changes to your models under the hood. That's going to be important, and we're going to touch on that later in this presentation. But a migration for Alembic typically looks something like this. You'll have an upgrade step. You'll also have sometimes a downgrade step. In OpenStack land, we don't tend to do downgrades because you shouldn't really be downgrading your schema. You should be backing up your database. And if something goes wrong, you should restore your backup. But yeah, it has the ability to both do upgrades and downgrades. Like I said, it can auto-generate these from your schema. You can also manually write them. And you can also, because it's Python code, do things like data migrations inside there, transforming data. Again, that's going to be relevant as we go through this. And Alembic itself provides a command line tool called Alembic, funnily enough, that allows you to interact with your migrations, to apply them, to see the current status of them, generate new ones, and so forth. Because it's all Python, it's designed to be extensible. So you have the ability to write your own wrapper tools around this if you don't want to use Alembic, if you want to add additional functionality. Again, this is going to be relevant later on. In OpenStack land, a couple of the projects have done exactly that. They've provided, for example, custom DB managed tools that allow them to expose some, say, project-specific functionality to the end user. So when you combine Alembic and SQLAlchemy in an application, you'll end up, a very minimal hello world application will end up looking something like this. There's two things that are relevant here. The first is the migrations directory, which contains a whole load of metadata, including the actual migration files themselves. The env.py thing is the thing that configures your Alembic environment. Ignore the README. The script is your base script, as you'd guess. They use macro templates for some reason instead of Ginger. I don't know why. I think it's switchable. And then the versions contains all your actual migrations. And as you may have noticed in this slide, the Alembic doesn't insist on a sequential upgrade order. You have the ability to do things like branches. Again, I'm going to touch on that in a bit. But it means that you can have a tree of migrations. You have the ability to develop, we'll say, a feature that adds new tables on a feature branch and then merge it in without having to worry about rebasing your entire series and reworking all of your migrations. Again, this is going to be important later on. So the problem that we're looking at here today, going back to that original model, we'll say you have a very simple user table. I took this from the SQLAlchemy introduction documentation and modified it a small bit, and it has a first name and a last name column. There's that blog that's been sitting on the internet for years, like 10 things developers falsely believe about names. And one of those false things is that everyone has a first name and everyone has a last name. We'll say you want to go and fix this in your application. You say, okay, you're going to combine the two of these into a single name field, and you're not going to do any kind of validation on it. You're just going to let a user, tell you what their name actually is. How would you go about doing this? So if you were to use if you had Alembic configured so that you could use, we'll say, order generation, and you went and generated your revision, a point on this, I'm going to share a link to a blog post at the end of this. So all of this code, plus a link to a GitHub repo and stuff, all of this code is available. So don't worry about the actual important code. But if you were to try and auto-generate a revision, it would end up doing something like this, adding your new column and then immediately removing the old stuff. You can manually modify that to add data migrations as part of that schema. But there's a couple of problems with this. The first is that you obviously need some downtime for your application. So we'll say your application is running, you need to take at least the one instance you have down, do your database migrations, and then restart it again. That's okay for, we'll say, a little Flask app that isn't all that mission critical. Not so great when you're a telco or something where you're talking about 5 nines reliability, and if you don't make that, the government sues you. And also, if you have an application that's designed to be horizontally scaled, you have multiple instances of your application talking to the database. Obviously, all of those things, they need to be talking to a consistent backend on this thing, which means they all have to come down again. And lastly, the actual database upgrade itself, typically MySQL, if you're doing certain operations at the table, will lock the entire table. And that means you can't add, remove, do any modifications to that until the lock is lifted. That can take minutes, possibly hours, for particularly large tables, which isn't acceptable. So, as I've noted, to do this in one go, we need to shut down our instances, and we want to avoid downtime. So, an initial solution to this, I may say the solution, is a pattern called expand contract, also known as expand migrate contract. So the basic idea behind, actually show of hands who's used this pattern in their own application. Excellent. So yeah, for anyone that hasn't used this, the basic idea behind this is that you split your migrations into 2 or 3 steps. The first of these is the expand step, where you'll actually go and add your new columns, your new tables, whatever new, not necessarily new constraints, maybe less constraints to the table or to the database. You'll then have a migration step. This will either be done via data migrations using a tool like Alembic, or it'll actually be done by your application at runtime. So we'll say you could stay in that middle stage for a week or 2, allow your application to load data in, modify it, and save it back. And then at some point in the future, possibly the distant future, you'll run a contract step where you'll remove the fields that are no longer necessary. So in this case, we'd add our new name as part of the expand phase. We'd migrate our data probably at runtime or in Alembic migrations from the first and last name fields into the name field. And then eventually we'll be able to drop those because they're no longer necessary. So a very hacky first pass way of doing this is to take that migration that we had initially and split it into 3 migrations. So we'll say you have your initial expand migration, you'd have some background task that's running, or we'll say another migration to do your data migrations, and then at some point you'll have your contract migration. And just toggling between the 2 of these, you'll see the down revision here, this 9C, is obviously the revision of the previous one, so it's all sequential. So if you were to go and actually apply this, you'll notice, for one, you have to specify hashes. It's not all that nice to do. If you were to use your standard Alembic upgrade head or heads, depending on how many branches you have, you would automatically apply all of those contract things, which would not be good. So a slightly better way of going about this is to start looking at that feature I mentioned earlier, which is branches. So branches are typically meant in Alembic for, we'll say, the ability to develop things like features out of tree and then merge them back in without having to rebase. As the Alembic docs here note, that a branch describes a point in the stream where 2 or more versions refer to the same parent migration. So same as a branch in Git. What we can actually do with this is we can use branch labels to label our initial branch, or our initial, we'll say, expand branch. And what we'll end up with is 2 separate branches, one the expand and one contract. So every time you upgrade your application, you'll have the ability to go and apply all of the expand migrations up to the latest, or using, we'll say, a lower version if you want to do it step by step. And then similarly, once you've done that, once your application has run for a while, you'll be able to go and run your contract migrations. And that ends up looking something like that, which is a slight improvement again, but we can obviously go further. So I've used scare quotes here because there's obviously way more things we can do than what I'm actually going to suggest here. I'll go into that at the end, but going back, I said at the beginning that Alembic has the ability to auto-generate stuff, but when we tried to run auto-generation on this, dummy example, it generated a migration file that contained both the expand and contract style migration patterns or migration operations. So what we'd really like is the ability for Alembic to actually generate separate branch or separate migration operations belonging to different branches depending on what type of operation we're trying to do. So as I've noted, SQLAlchemy is really extensible, so is Alembic. This is, as I've indicated there at the bottom of the slide, this is from your env.py file, which is the thing that configures your migration environment. Inside in that run migrations online function that it will automatically generate when you create a new Alembic project tree is this context configure, which, as the name would suggest, configures your entire environment. That accepts this thing called process revision directives. And if we look at the docs for that, this is a function that allows you to modify the operations that Alembic's generating. So normally this would be, for example, you wanted to change the output path that your migration files were being saved to. You wanted to inspect them to see if there was something funky going on, or to maybe rewrite them a small bit. We're able to use this as an entry point to start splitting our migration operations into separate files. So from here on out, I'm going to be showing a lot of code. Like I said, this is all up on both a blog post and on a GitHub repo, so don't worry about it. It's mostly, we'll say, the bigger picture that's relevant here as opposed to the code itself. So that file, that process revision directives, you point that at a function, and that function accepts a couple of arguments: the context, the revision that you're trying to upgrade to, and then a list of the directives that Alembic has automatically generated for you. And when you have that list, you have the ability to go and modify that list. So if anyone isn't familiar with that particular operation here, the directives and then the colon inside the square bracket, that's effectively saving a list overwriting the contents of the list as opposed to redefining the variable. So what we're doing here is we're overwriting the contents of that directives based on this, the output of this assign directives function. All that that's doing is iterating through every directive that Alembic has automatically generated for us, and it's feeding it into this thing called dispatcher. So a dispatcher, under normal circumstances, is the thing that Alembic uses to decide what the SQL for a particular migration operation should look like, depending on your backend. So obviously, if you're using MySQL or Postgres, you're going to have different types of auto statements because they've got different syntaxes. If you're using something like SQLite, you're not going to be able to modify the tables because SQLite doesn't support the auto operation outside of some like toy examples. But what we're doing here, and this is only one potential way of solving this, is to use this dispatcher to effectively filter out our operations into different functions that allow us to make decisions on what we do with those functions. So you'll see here I've got a bit of logic that figures out what phase I'm in, a phase being either expand or contract, and then it feeds it through to a decider or the dispatcher. So looking at the first of these, the highest level operation that Alembic is concerned with is the generation of the migration script itself. This is, we'll say, your checksum or your hash name of the file.py file that you'll find in that versions directory. All that we're doing here is we're effectively generating the exact same migration script we would normally have generated with two exceptions. The first is that we're filtering the list of operations based on the current phase we're in. So we're going to filter out contract style operations when we're in an expand phase and vice versa. And we're also saying that the head of this migration should refer to the current branch. So we want it to continue in a vertical stream or two streams the whole way up. And then the ops is empty thing is just copied. Looking at a little more concrete example, these are the things that we can class as expand style migrations or expand style migration operations. So adding constraints, creating indexes and tables, and adding new columns. So we've said that if we're in an expand phase, these are things that we want to do. We want to emit to our migration scripts. If we're in the contract phase, then we obviously want to skip over that. Likewise, for the contracts operation, we want to only handle things like dropping constraints, dropping columns, and so forth. And then finally, this one's a bit weird, altering columns. Most of this stuff is based on what we do in a couple of projects in OpenStack, and we've made a decision in OpenStack that the only thing we're going to support from an order generation perspective is the modify nullable, or the null attribute of a row. Everything else is a bit weird. So for example, if you're modifying a server default, is that an expand or contract operation? If you're modifying a help string, this kind of thing. So as you can probably see there, all we're saying here is that if we're setting a thing to allow null, then that's classed as an expand operation because it's making the thing less restrictive, the schema. And likewise, if we're making it more restrictive, that's classed as a contract operation. And then this isn't really relevant, skip over there. So with that done, we have the ability then to go and run our Alembic revision auto-generate, feed that through, and we'll, if we go and look in our versions directory, we'll notice that we have two separate files. One is generating all of our expand style migrations, and the other one is generating all of our drop style migrations. The down revisions, like I said, they'll maintain consistent branches, and when you decide to actually go and apply this in production, you will first apply all your expand migrations, then you could potentially have another branch of migrations to do all the data stuff, or you could leave it up to your application, and then at the end you'd have your contracts at some point in the future. So in terms of next steps, things that you could do from here on out, there's a whole load of improvements we can make. For one, going back to this, you'll notice that the file names, there isn't a whole lot of difference between them, and it's only when you actually go and inspect the path that you'll actually, or the contents of the file, that you'll realize which branch they belong to. It would be lovely if we were able to disambiguate the expand and contract style migration operations from each other, either by file name or by putting them in separate directories. So, yeah, filter those out. It would also be nice if we could do checkpoints. So for an internal application, we'll say not an open source thing that you're not expecting other users to deploy, this is probably less relevant. But if you're something like one of the OpenStack projects where you would expect people to be, we'll say, jumping multiple releases in one go, it would be really nice if you were able to apply your migrations in a step-by-step pattern. So instead of doing, we'll say, expand and contract, taking a look at this example of a custom application that the Neutron project in OpenStack has, they give you the ability to apply all of your expand migrations based on a release, Z being one of the release names, and likewise for the contract migrations. You can also obviously add a whole load of tests. It would be lovely to make sure that you or another developer aren't adding contract style migration operations inside in the expand branch, because you're in for a bad time if you do that, and so forth. So all of the code for this, plus a big massive blog post that actually goes into this in a lot more detail, is available there. That QR code I'm hoping should work. If not, that's a fairly short URL. I'm available to take questions, and other than that, thank you very much.
A nice talk. One question I have is, like, I felt in having a linear migration helps in long term of understanding, like, sequence of things has gone into the production, and
Yep.
if you want to roll back. Does expand contract pattern at finally, do you squash a migration so that after completion it comes into a single state, so it becomes easier? Is that possible?
Yeah, yeah. So a thing that, again, I'm going to talk about OpenStack projects, but it's not really relevant. It's just a good concrete example. A thing that the Neutron networking projects did was, if we go way back to a sample migration, you'll see this down revision. If you specify that down revision, we'll say if you're on the expand branch and you specify that down revision as something on the contract branch, you'll basically remerge this thing back in. So you have the ability to branch off. You also have the ability to merge back in. So you can make a decision at some point at a major release version that you're effectively going to squash previous migrations and just go back and either manually modify things, insert a new migration to kind of close the branch back, that kind of thing. Yeah, it's all, I think it's a, what's it, directed, what's the A stand for? Something graph, DAG. Thank you. Yep. So yeah, perfectly possible.
Any more questions? Hi, I have actually two questions, right? So you talked about basically, having this expand and contract style migrations. But usually, when you have a production style application, you cannot always put, all the test cases or cover all the kind of, edge cases. So when you're testing, so could you talk about what's your approach, kind of having a kind of a monitoring system, if you wish, if you're using, Flask app? That's the first one. And secondly, if in case you kind of, your migrations kind of fall through your testing strategy, what's your approach for, doing rollbacks or handling, like the those kind of cases?
Gotcha. So again, I'm going to talk from not a Flask app perspective, but from an OpenStack perspective. So we've 3 separate things that we do to make sure that our migrations do what they are supposed to do and they don't introduce bugs. The first of those is code review, effectively. We have multiple people. OpenStack has a policy of like 2 core reviewers, like 2 plus 2s, because we use Gerrit. So for any given migration, at least 3 people should have looked over that migration. But obviously that's fallible. People are fallible. So the second thing we have is we've extensive unit tests for all of our migrations that actually insist that contract operations aren't allowed into particular branches. We also have we'll say in certain projects, we'll have a list of migrations. We have a white list of migrations that are allowed to do certain things. So we'll say in the Nova project, we never allow dropping tables unless it's been at least 4 releases, just in case we made a mistake and we end up wiping a whole load of data. We'd rather have redundant data left in the database unused. So to remove a database, you have to go and manually modify a variable somewhere and add it to that list, and there's a big massive block of text saying don't do this unless it's been 4 releases. And then the third step is we have upgrade testing. So we'll do it, there's a thing called grenade, we'll deploy the application and then we'll run it through an upgrade and we'll expect the exact same set of tests that passed previously to continue to pass. We don't tend to do rollback testing because, as I said, we don't support downgrade operations. We expect users to back up their data before they do enter into any kind of upgrade. I think that's the 3 of them. Did I answer your question? Do you want to clarify it again? I'll take another go.
Yeah, I think I get the idea of that, but you know, sometimes my experience has been that when you're dealing with, say, Postgres, you know, then they have kind of a lock timeout, you know, issue kind of occurs when you have lots of, you know, users, and you know, even if you do a backup, you know, between the backup and between the time when the migration is applied, you know, that window is kind of the critical which we kind of face issues, you know, but yeah, I think it's kind of helpful anyways, yeah.
Yeah. I don't have a very good answer for you. The main thing that we're relying on is the fact that the expand operations shouldn't be in any way destructive or increase restrictions on the schema. So you could end up with unnecessary stuff in your database, but you should never lose information. And we do rely a small bit on, we'll say, operators doing things in the correct order. They have to upgrade their database before they deploy the new code for the application. If they do it the wrong way, they're in for a bad time, and there's, you know, we can only say you didn't read the docs or you overrode your tooling. Yeah, I don't have a great answer for you, unfortunately.
Yeah, no worries, thanks.
No worries.
Actually, I have a question. How do you connect this with the CI/CD systems? Like, what I'm trying to understand is there like any approach for tagging your release or code changes so that the upgrade system will automatically pick up, like, you know, when you encode, you can specify what phase this should fit into, like a directive rather than, so do you have any antidotes about that?
Sorry, so do you mean from the perspective of generating the migrations or applying them?
More of like a generating. So this plays very nicely when you have, like, I'm talking about like many microservices accessing a same database probably. So, you know, so you don't really change the database through your microservice, but you could just kind of, you know, direct it, like tag it. Okay, this is the phase my application code is going to change.
Yeah, gotcha. So your application would be, I guess, inspecting your database and it would know what version you're currently at. No, we don't tend to do that in OpenStack. We tend to insist. We have the ability to do versioning for things like messages passing over message buses, but for the database itself, we tend to insist that you have the latest database schema, with the idea being that your older applications, because you wouldn't have applied the contract migration yet, your older application versions would still be able to talk to, we'll say, they still have the first name and last name column there to pull information from, and then the newer ones would know that those fields have now been combined and would be able to talk to those directly. So it's more that we make sure that the schema is permissive enough to allow multiple applications to talk to it, as opposed to insisting that those applications probe the database to see what version's there, if that makes sense. Good.
Thank you so much.
Cheers.